This is problem number 6 for section 2.1. It says find the slope of the curve y equals x cubed minus 1 at the point P 1, 0. By finding the limiting value of the slope of the secant through P, find an equation of the tangent line to the curve at P 1, 0. So we have this curve, right? It's not straight. It's not a straight line. We want to find the slope, and they say use secant slope. So we're going to use this secant slope equation, which is the f of x plus h minus f of x over h. And then, because we don't want secant slope, we actually want tangent slope at this point P, we're going to use the limit as h approaches 0. And remember, h is like the distance between the 2 points closing to be 0. So it's like those 2 points that we're finding the slope with, we're closing that gap to being basically 0, meaning we're finding the slope at a specific point. So the first thing we want to do is use this equation with this function here, this curve. So we start by taking x plus h, plugging into the function, and when you plug it into the function, you get x plus h cubed, right here, minus 1, and then minus the function itself, x cubed minus 1, and that's all over h. So it's x plus h cubed minus 1 minus f of x, right, which is just x cubed minus 1. Now at this point, we need to figure out what's x plus h cubed. So x plus h cubed, I kind of have this worked out just a little bit, is x plus h times x plus h times x plus h. And we already know x plus h times x plus h. X plus h times x plus h is x times x is x squared, x times h is xh, and then h times x is also xh, that's 2 of them, plus h squared. And then you're multiplying it times x plus h. So when we multiply all of this out, we get x squared times x, which is x cubed, x squared times h, which is x squared h, 2xh times x, which is 2x squared h, 2xh times h, which is 2xh squared, h squared times x is h squared x, and finally we're going to get, I'm going to slide over to get this on the page, we're going to get plus h cubed, because we take h squared times h, and that's going to give you h cubed. So this is what x plus h cubed is. Now we can combine some stuff together. This can combine with this to make 3 of them. This will combine with this to make 3 of them as well. So we really get x cubed plus 3x squared h plus 3x h squared plus h cubed. And then if we distribute, right, so this is just this x plus h cubed, then if we have the minus 1 afterwards and we distribute the negative, we get minus x cubed plus 1 all over h. Now let's go ahead and cancel some stuff out. So we're going to cancel out the x cubed with this x cubed. We're going to cancel out the 1 and the negative 1. And we end up with m equal 3x squared h plus 3x h squared plus h cubed all over h. Now we're going to factor an h out of the top, so we end up with m equals h 3x squared plus 3xh plus h squared all over h, and we're going to cancel the h out. So now we have m equals 3x squared plus 3xh plus h squared. Now this is the expression for the slope at any point on this curve. The last thing we need to do is, or I should say, this is the secant slope. What we do next will then find the expression for the slope for any point on the curve. So this is the secant slope between obviously like essentially any 2 points. And then we're going to take the limit of that as h approaches 0 to cancel some stuff out. So we're going to say for the tangent slope, we're going to go ahead and say limit as h approaches 0, and we're going to plug in 0, and we get 3x squared plus 3x times 0 plus 0 squared, and this ends up being just 3x squared. And now we want to use our point P, so let's use point P, which is 1, 0. And when we use point P, 1, 0, we're going to plug in x is 1 into here. So m equals 3, 1 squared, which is 3. And now we want to do a tangent line for part B, right? So this was part A. Now for part B, we want the tangent line. So we go y equals 3x plus b. We plug in 0 and 1, or 1 and 0. So we get 0 equals 3 plus b. We subtract the 3 over, and we end up with negative 3 equals b. So our equation is y equals 3x minus 3. This is the tangent line to, or at the point P, 1, 0 on this curve here.